Okay, very good. This is a good problem because if you remember, there are two possibilities. Either this, in general, I'm talking about in general now, or this. I know that this one is nice. It's a chain. I like this one. I don't really like this one because it's the opposite, the outside. Greater than or equal to 2 or less than or equal to -2. And the solution has to have the union. So obviously this is much more complicated. When the absolute value is less than or equal to 2, done. But when it's greater than or equal to a positive number, then I have all this thing to do. And that's the situation here. But I notice that inside I can factor out 9. And look how nice. This disappears. And I have a much easier inequality to deal with. But it's still two options and two separate options. That's what it makes it more difficult. I have x plus 1 to be to the right of 2, or x plus 1 to be to the left of -2. So now, from this moment on, it's easier. And I see x greater when I subtract 1. And here I subtract 1. I know that the solution has to have the union. I prepared the union already. This one is to the left. And this one is to the right. Yes, it's much more work than if it were less than or equal to 2. But if I remember that I have to have the union, I remember that it goes this way, to the right of 2, to the left of -2, then I'm fine. So this is the solution in interval notation. Is this okay?
Yep.
So please remember, this topic is not difficult. There are only two options, not 15, right? Only two. If the absolute value is less than, nice. If the absolute value is greater than or greater than or equal to, more complicated because I'm looking at the outside, not in between. Not between -2 and 2, but to the right and to the left. The right of 2, but left of -2. And the answer has to have the union. Next question.
We do 3 and 4 on the final.
Yes. Okay, let me look. Okay, very good. So the first one, I see it's a polynomial equation. I see it has degree 3, and I know that I have to come up with 3 solutions. Real, imaginary, whatever. But I have to have 3 solutions. I have to move everything to one side. It has 4 terms. And 4 terms is always grouping. Always. Okay. I move everything to one side. So x cubed plus 2x squared minus 36x minus 72 equals 0. I'm not ready with my props. I look at the first two. I realize that x squared is out. I don't care what I have here. If I cannot bring out an x plus 2, then I am not on the right track, or the polynomial is not factorable, or whatever. Negative 36. Oh, this is not good. So then x plus 2, x squared minus 36, and then x plus 2, of course, x plus 6, x minus 6, And I found what I needed. -2, -6, and 6. Any questions on this before we move on? Any questions? Now, we also wanted to look at number 4. Number 4 is a radical equation, and this is power 1/2. It's separated. The radical is alone on one side. It doesn't need any prep, and everything else is on the other side. So, but if I don't remember that this has 3 terms, then I will never solve correctly, or solve. X squared minus 2 times the first times the second plus the second term squared. If by mistake I write 2 terms, I will be crying if I see that, so keep that in mind. And the whole thing is not gonna help, right? The left-hand side is nice, 14. So now I move everything to one side. It's quadratic. I have to come up with 2 solutions. But then I have to go back and check. If I don't check, I cannot get full credit because I squared both sides. And this procedure may come up with false or extraneous solutions. So when I move everything to one side, x squared, I subtract 2x, and I subtract 14. And then I factor into x minus 1 and x minus 11. And I get at x equals 1 and x equals 11, but I don't know for sure. The original equation, this is not the original equation. This is the original equation. I know that 1 will not work. Look, this side is 1 minus 5, which is -4. The square root is always positive. So this cannot work. So the square root of 16 is 4, but 1 minus 5 is -4. Are they the same? No. With 11, 11 minus 5 is 6. 22 plus 14 is 36. The square root of 36 is 6. Yes. So see how important this is? Because we used a procedure that may or may not give us the true solutions. But we don't have another method. We have no choice. Any questions on this problem? In the meantime, I would like you to teach me, because I learn from my students a lot, what I should change, assuming, I mean, in the spring we're going to be like this. But in general, what I should change, how should I involve my students? How should I motivate my students more? How should I engage my students more? What should I do? I'll be more than happy to listen and learn from you. Something that works. Good. Next question. Anyone else?